Okay, folks, into our second lesson, I'm going to start with your assignment. Okay, I will set this on Plus Portal and I will attach this document to it. Okay, the first page looks like this. It's about the Bahamian platform. Okay, there's some very simple questions, and there's 4 pages. Okay, there's not very much work in it, so you can write these out and send it to me, or print out the sheet and fill them in there. To begin with, I'm going to go through each question and tell you a little bit where you can find it. Okay, this first one, A1, that'll be in your notes. We'll cover that today in later videos. Okay, name 2 important banks. All right, that was on page 7 of the Bahamian Landscapes textbook. Should be able to probably do that from the map above. No, but it'll be on page 7. Okay. B is on page 57 of Bahamian Landscapes. Again, pretty simple, but if you need help, page 57. Question C, identify and describe the rock that makes up the Bahamian platform. That's page 22 or 24 of the textbook. Okay. D, explain how the Bahamian platform is similar to that of North Cuba. That's on page 10. All right. Then C1 and C2 are both on page 61. All right, so you should be able to find that fairly easily as well. And finally then, F is a picture of San Salvador, all the ridges and the different lakes. All right. And then the questions, there's 2 questions, part 1 and part 2, about San Salvador and how people use the water and so on. This is in the notes that we'll add today. All right, and again, page 65 to 69, any landforms associated with ridgeland. Okay, this diagram or picture itself is in the Bahamian Landscapes book on page 62 as well, if you want a clearer look. Okay, but that's your homework. It'll be attached in an assignment on Plus Portal. All right, we're going to skip over very quickly to a PowerPoint, and you can head up in just a moment. Okay, so we can just head up with this. Okay, there's your details. So Bahamian Landscapes, we're looking at Rocklands now. The assignment you just did, the assignment for this lesson that we just looked at is all about ridgelands and the Bahamian banks. All right, so you can look back at the last 2 lessons and the page numbers I just gave you for all of that. So just 1 or 2 little bits here. What I want to do is, okay, now there's 2 little slides just like this. Okay, I just want to try and break it down. I was looking back over some of the content we've covered, and I just want to go through very basically how sediments form and then how they lead into sedimentary rocks. The whole Bahamian platform, all the Bahamian banks are made out of limestone, this oolithic limestone. Okay, so I want to roll back and get a simple flow diagram. Step 1, 2, here's some examples, step 3, step 4. Okay, of how these sediments are actually made, and then how the sediments go through a process to form our limestone, the rock and stone that make up our islands that you walk on every single day. All right, so look, it's a lot of writing, but I want these written down. You don't have to lay it out like this. It can be 1 line of boxes as long as the arrows are correct. Okay, or you can do it over and back a page, but this just takes you through how the sediments are created first of all, and then the actual rock itself. All right, so again, firstly, sediments need to form, but how? There's chemically, biologically, or physically. Okay, so erosion of the coasts of the existing rock broken down into small pieces. Biologically, from dead remains, skeletons of organisms. Okay, as they break apart and decay down, they become smaller little pieces and pile up together. Or chemically, through the evaporation leading to the precipitation of sediments in the water. We'll look at this one on the next slide in more detail. Okay, 2 examples that occur in the Caribbean. 2 examples of this breakdown. First of our skeletal sediments. Okay, so our biological parts or pieces of living or dead organisms, shells, parts of bones, all sorts of stuff. can start to break apart. Okay, sea urchins break apart over time. At the same time, you've also got this chemical reaction, crystalline grains. So material chemically changes its crystalline form. So again, calcium carbonate is the one that we always go to for limestone. All right, it should produce calcite. It most regularly does, but it can also be changed to form aragonite grains. And we all know that aragonite sand is the type of sand found in our area. So another thing that happens in the Caribbean, or in the Bahamas specifically, is that the calcium carbonate, there's so much of that in the water, okay, that some of it changes and produces aragonite instead. So this is where the sediments come from. All right, these sediments are then layered up slowly and cemented, should be no A, cemented together and harden into rock. Okay, we looked at these words cementation in the lesson before the Easter break. Lithification is where they layer up and they compress together to become rock as well. All right, that's why when you look at sedimentary rocks, there's always those strata or layers in it. Rocks are made, such as limestone, which is a sedimentary rock. Bahamian limestone is made from oolites and is called oolithic limestone. All right, so there's your little flow diagram about where and how these sediments are made. What about oolites or oolithic situation? Okay, oolites form through a chemical process. All right, so we had chemical here. This is the example for oolites. As the ocean water moves over the shallow Bahamian banks, it begins to heat up. When you look at the Bahamas from space, okay, you see that turquoise clear water, and it becomes very shallow. All right, when the water is shallower, it's easier to heat up because light can penetrate deeper into it. This causes water to be evaporated and will also leave behind or drop the tiny grains of calcium carbonate it's holding. So as water is evaporated, okay, that means it's full of stuff like salt and this calcium carbonate. All right, so it can't hold all those things because there's less water now because some of it's evaporated. These tiny materials begin to clump together as the water can no longer hold all of them. All right, so now you start to get these grains. As the clumps get bigger, an ooid is formed and sinks to the bottom of the sea. Very simple. Over time, they begin to layer up and cement together to form our oolithic limestone. All right, so again, there's your little flow diagram of how all of these things come together. All right, so what we're going to do is, we've got our assignment looked at, we've gone through a little bit of background. I'm going to jump over to page 71 of the Bahamian Landscapes textbook. There's a lot of stuff to go through. Okay, so we're going to do that now. Let me pause this and I'll see you there in a few minutes. Okay, so let's make a quick start. All right, just another minute on this video and then there'll be a second one. So we're on the Rockland Landscapes, page 71. Okay, and I'm going to fly through this really quick. It's pretty self-explanatory. This is the flat and rocky land without vegetation, and without vegetation it would be undoubtedly a stony desert. All right, so if there was no vegetation, it would just be like a stony desert. I've underlined the word flat. Okay, far flatter than the ridgelands. So if you were to compare both, the ridgelands would be much higher land, okay, or steeper land. Extensively on the bankward sides, okay, so it's found further inland than ridges. Ridges tend to be found along the coastal edges of our islands, whereas the Rocklands are inland, all right, especially in the Pine Islands, so all the North Islands, Andros, Abaco, Grand Bahama, and New Providence. As a landscape, these areas are more notable for their vegetation. There's a lot more vegetation than on ridges, and their relief. So their height isn't remarkable. Ridgelands are all about the height, but here this is about more vegetation. Rocklands are lower, so they're closer to the water table below the surface, so more vegetation can grow. Okay, Rockland is covered with thousands of acres of pine trees. So again, if any of you, I know we've had some people do DOV, if you've ever headed out west around Lampo City and some of those out near the airport, there's wide expanses of just pine forest, all right? Much Rockland started out as shallow water banks of oolite, okay, when sea levels were higher than at present. So again, a lot of the Rocklands would have actually been underwater, and as the sea levels have dropped, they've now become above the surface. All right, continue the second video as we work through this text very quickly. All right.